Good evening, everyone. This is the Building Operators Association April meeting / webinar. So it's April 12th, 2022. And my, how time is flying. A couple quick notes. I want to remind everyone that if they did not receive their magazine via email, then you can go onto our website, which is www.boacalgary.com, and you can download the magazine there. And also there will be a link to this webinar, or you can go onto YouTube and watch a replay of it there. And I see we've got a few people here. We've got a good bunch. Let's see, holy smokes. So hi Grace, hi Kyle. I already said hi to Monica, and hi Randy again. So today we've got a little bit of an interesting one, but maybe before we get into that, I'll just mention that we'll be going back to in-person meetings in September, and that'll be, we'll have to look here and see when it is in September. I don't have that memorized. Let's see. So it's always every second Tuesday of the month, so that would make it September 13th. And so that'll be at the Danish Canadian Club. And I think on 10th Avenue, I think everybody knows where that is, 10th Ave, 7th Street. And we'll figure out before then if we may tape the speaker and do this thing on YouTube as well, because we're building up quite a library of stuff now. So might as well continue with that as a resource to you guys. And also we will be holding our trade show on October the 18th, which will be basically all afternoon on the 18th, again at the Danish Canadian Club. So again, mark that on your calendar for attending. So that's usually pretty good. I think we've just kind of, we haven't really even formally announced it, have we? And we already we're more than half full. So it's good. It should be another good one. It's been many years since we've had one, because of course the one that was scheduled in 2020 we had to cancel because of COVID. But so anyway, it's been 4 long years. Wow. So anyway, do we have any other announcements left before we dive into this?
No, you're right. We are a little excited about the trade show. That's, we're finally going to get together, and same with in-person meetings is pretty exciting too, because these webinars are really a worthwhile event, and it's nice. And I think we'll continue on keeping them as a file history. And I think the meetings that we have as well should be recorded, because one of the nice things about it is that when you have a guest speaker and you only have 30 people show up to the meeting, and we have, well over 200 members, if they can't make it, it's always nice to have that library. So we're going to continue on recording these meetings. Also, I'd like to put out, because we are poor as church mice, and we do have sponsorships, and we're always looking for people to pay their memberships, which is fairly inexpensive. It costs you $65 to be a member. If you want to support us in another way as a corporation, we have different levels of sponsorship. We have platinum sponsors, and I always like to say that, put a high out there to our platinum sponsors, which is Epic Buildings, and same with Cougar Technical, as well as Gentech Field Services. Those are our platinum sponsors, but we have other levels of sponsorship as well. And so it's through their generosity that we're able to do these webinars and educate building operators, because that's really our whole focus, is the education of the operators and by people that are subject matter experts. Grant Eliuk is a perfect example of a subject matter expert, kind of retired, but he's still worthwhile listening to, worthwhile having him in our library for people to draw that information from. So I'm not really got much more to say than that, but thanks for doing this as well, Mark. You're such a wonderful host.
Yeah, no problem. So yeah, we the two of us or three of us may be retired, but it's always a pleasure to stick our tongue out at everybody else that's still working to pay our pensions. So it's all good. And also it's a resource to everyone out there, and you don't have to be a member to watch the webinars and all that kind of stuff. We put it out there. It's for everybody. So anyway, we might as well get on with this. So what our subject is, it's an introduction to energy performance and thermal imaging for buildings. And our guest speaker is Grant Eliuk. And I always mispronounce that, Grant, on purpose almost.
Everybody does.
Anyway, whatever. I guess, some of us, we've known Grant for many, many years. Grant is years ago participated with BOA and as a member, and also has given at least 2 or 3 presentations in the past on thermal imaging and all that kind of stuff. This one's going to be a little bit different. It's a little bit more on building envelope but towards, it's also going to be about thermal imaging. It's basically about the tools we have to be aware of, or the big picture we have to be aware of when we are planning to do things in our building or investigating where things are at with the building. And the important takeaway is one has to realize how much one system affects another. And so if you're making changes to the envelope or changes to the HVAC or even on the electrical, they all work together. And so when doing things to one system, it may affect the others. And so you want to make sure that you're looking at the complete picture so that you're driving to the best result in the end. One thing that I'll just mention briefly is our illustrious federal government has, from time to time, they do come up with some good things, and they put out a little publication, and it talks about. So this is the Office of Energy Efficiency. So you can go onto their website, and Natural Resources Canada, Office of Energy Efficiency. And so they've got a new bulletin out in a PDF it's called Tuning Up a Framework for Existing Building Commissioning. And it's not overly technical, but what it is kind of a step-by-step guideline of all the things you need to go through or look at or consider, and also has an incredible list of resources when you're doing a recommissioning process. Now, some of the things that we're talking about today could be done in conjunction with your building recommissioning, or a part of, or in conjunction to, or so again, it all ties in. And so I just, you know, if anybody's interested, you can download the PDF on their website, and it is a pretty good guide. And there was, I'll just give a shout out to some local participation in it, and that was from CMS, what is he, CFMS Alberta, and then Craig Hatch. So I just saw him in the acknowledgements there when I was reading it this afternoon. So I thought, oh, well, there you go. And then there's stuff from every province. So anyway, there you go. It's a resource to you. It's got lots of stuff in there. And it all kind of relates to what we're going to be talking about here. So anyway, so Grant is, again, we've all known Grant for many years, but so Grant is a guru on thermography. So he has his level 3 infrared thermographer ticket or whatever it is. And he's got a whole list of, you're a certified energy appraiser, applied thermographer for electrical, mechanical, building envelope and roofs, special hazards and process, all kinds of stuff there. The list is longer than that, but happily retired in downtown BC, downtown Columbia. So good for you, Grant.
Yeah.
And with that, take it away. You can share your screen and then introduce the other 2 participants you're going to be are going to help you out with this endeavor.
All right, let me get the share screen going here. There we go.
There you go.
And we want to go big screen on this.
Yeah.
Oop.
Oh, you did the line. There you go. Close
There we go.
enough.
There.
Take it
So-
away, Grant.
Today I wanted to talk about just what it says, an introduction to energy performance and thermal imaging for buildings. We invited Ben Hilbrandt. Is that close? Ben is from SAIT. Okay, Ben is from SAIT, and he's in the Green Department, Building and Teaching. And Gene, I believe, will be joining us.
He just did.
Oh, did Gene join?
Yeah.
Yeah,
He just
okay.
has himself muted right now.
Okay, so Gene is one of the teachers in the glazing department. And both of these gentlemen are truly experts at building envelope design and new technologies. Gene will be talking about continuous thermal breaks. And Ben will be talking about old and new designs for building envelope. What else should I say at this point? Myself, I'll be picking up the tail end and talking more about PM, maintenance, and PPM, which is predictive preventive maintenance, so that we could build a proper due diligence program for buildings. The first thing that I want to say is on energy and on physics side of it. Energy in has to be energy out at 100%, because energy cannot be created or destroyed. It can only be changed. So saying that, it's a huge subject, and we're not going to be able to cover it all. That's why we decided to name this Introduction to. So we will be talking a little bit about the guts of the building and how that runs in the form of stack effect today. But we're just going to touch on that. So this is why we picked energy out. So energy out is of huge importance, because although that you have electrical and gas and any other energy intake, it only goes one place, and that's where it goes is out your building envelope. So that could be roofs or the building envelope itself. Now we divide that into two because they are both actually quite large subjects. So today we're going to be picking on the building envelope, and hence the special guests that we have brought in. And I know Gene is in a gamma meeting. So we're gonna have to mix this up, Ben, a little bit. I wanted you to go first, but since Gene is here now, then we'll get him to go first, and then he can get back to his gamma meeting. Gene, are you there?
Hi, how are you guys?
Good. How are you, buddy?
Really well, thank you. Sorry about this. I'm kind of sitting in my truck at the moment. I'm at a Glass and Architectural Association meeting, so I'm bouncing in and out of both. But I appreciate you inviting me to this.
Okay, well, I'm going to scroll down to your screen here that I built up a little bit, and then it's got your pictures just below that. So, Gene, can you give us your last name? I don't know how to pronounce it.
Oh yes, I should have introduced myself. Sorry.
No sweat, buddy.
Jack Bellini. I've been in the glazing industry. I'm a red seal journeyman. I've been working within the industry of glazing for 20 plus years, and I've been fortunate enough to be instructing in the glazing program at State. Oh boy, this August I'm going to be hitting year 15. So I worked for one of the major players within the glazing contractors. Oh boy, many years. We owned downtown at the time, and worked with all the building owners. Worked with a lot of building envelope specialists on failures. So a lot of my job consisted on, a lot of people called me a leak geek. So why building envelope failures were happening, occurring, and what was the reason and how to go about repairing them.
Okay, so do you want me to bring up the pictures and we can go through that, Gene? And you want me to step in and be in a glazer as well? So there's the first one that you sent me there.
Absolutely. So we're looking at a typical curtain wall section. The curtain wall systems are used from anywhere of a light commercial building to a multi-story high-rise situation that consists of course, a back pan, which what that does is separate and it separates and discloses the floor slab. And it is an insulated area that has a piece of spandrel glass in front of it. This actually area can contain a lot of heat and buildup. And so this particular area with the insulation and the single pane spandrel area is vented and being able to release that. You're looking above at the sealed unit situation. Again, in a curtain wall panel or a panel system, all of these are compartmentalized. So each opening is individually compartmentalized. They are made so that if any water penetration got through the system, that they will literally weep out and drain through the drain system. This particular system is done with what's called a vision strip. So it's a wet system to the exterior on the pressure plate and a bulb rubber gasket to the interior system. Still one of the best systems on the market. Comes in a different variety of systems. So in this particular item you're looking at, and I do have some pictures further, the thermal brake. So the thermal brake is actually applied into the nose, and that's where you actually see the screws of the pressure plate entering. Again, a thermal brake's purpose is to stop the transfer of cold from the exterior of the building through into the interior. Galvanized back pan is what you're looking at there, 20 gauge material. Now there's a lot of things happening on the market today, and due to old school installers compared to the new school installers that are out there, that the proper information hasn't been passed on maybe correctly, or it's not being designed properly. So with a galvanized back pan, it is so important that once it's installed or before it's installed, that the pan is actually sealed in the framing member. It is fastened into place with screws, and of course, then the screws are actually all sealed over. The back section, so the member in between the back pan and the sealed unit, these come in a various sizes, colors. And again, this is a typical 1600 series is what you're looking at.
Okay, Janine, can you go on and explain a little bit more about the continuous thermal break throughout as it goes up through here?
Yeah, so all of our materials, when you look at our materials that we're installing, the high performance value of them and the rating on them are super high. So this particular series with the applied thermal break, so really it is a rolled in, it's pressed in either by hammer, by thumbs, depending how strong you are, gives this frame a continuous thermal break, stopping the allowance of, again, cold transfer through. It is a good system. It does hold its value, its R value quite well. Although as technologies have improved over the years, now we start getting into, so the thermal break can also come in a rolled and be poured and be bridge system, where there's a separation actually in the metal nose, and the thermal break itself is poured right into it.
Sorry, guys.
Then, sorry about that. One of the pictures is there of it. I'm not sure where I sent it to you. I'm sorry.
No sweat. This. I was just. Can you see my cursor here?
I sure can.
Okay, so I was pointing out the thermal break that Gene was talking about, and here it is in continuous, coming down here. It runs down here, and here it is here on both sides, back and forth. So there's your continuous thermal break, and I think probably we should mention that on multi-floors, this thermal break is continuous all the way up the building.
Absolutely. Both vertical and horizontal members have this applied into it. The particular, what's moving on today, of course, is of course the high performance series. I'm a Conair specialist. The companies, two companies I worked for through my career were Conair representatives. Of course, now they've moved on to the glass nylon reinforced thermal break in their materials, which allows for, again, a dual pane sealed unit, or actually will even now carry a triple glaze sealed unit. That's still one of the better high performance models on the market today, and is becoming very popular.
Yeah, I totally agree, Gene, and I think that'll flow nicely with what Ben has to say as well, because of the new designs and old designs and whatnot of the building envelope. And what Gene was talking about is that nylon is right in about here on the nose, which is the new system for thermal breaks. And if you notice, it's in line with the sealed unit. Is that correct, Gene? Am I got that right?
You sure do. You're right on the money with that one. So the main part of the glazers, not only fabricating the aluminum framing and installing it with the glazing, but the main part of us is, of course, the building envelope and installation. Many years ago, of course, the glazers did all of the envelope on the building. And for some reason, within the last, 15 years, the prime contractors have now started to part that out, where we really just specialize within the area that we work, and leaving it to other contractors to complete and then meet into our system. It seems to have caused a lot of trouble, a lot of failures due to the fact that, the glazers are a they're specialty at this. What I have found over my career and years of working with, of course, the building envelope engineers in Alberta, especially using Alberta as, we're the only province really across North America environment that goes from, we can go from a -30 to a +10 within a period of 24 hours. Puts a lot of stress with the building envelope. And what we've been finding, the recommendation is always used when installation of the building envelope is done. Winter primer is always used, whether we're doing it in summer, fall, spring, winter. And the failures that we've been running into with the other contractors that are now involved in their portion of the envelope is they're not really up to date on this. And so maybe they use a summer primer, and all of a sudden that's starting to peel and fail and separate from the building. And so that's where a lot of the problems have been occurring.
Gene, are you talking mostly about the new EFB system where it's outsolation instead of the insulation?
No, I'm talking more about the use of blue skins and.
That's what I'm talking about too, yeah.
Yeah, that laps from our member that are mechanically fastened onto our materials that lap back onto the wall system. The new system that you're speaking of, the oscillation type, of course, is done in a light commercial industry, more like school steel stud buildings, steel stud erections, where light commercial buildings more like on the school level, where they're using a glass wall, it's called, or glass clad, as the exterior product that comes with like a Tyvek already applied onto it that we then tie into. One of the biggest problems I found throughout my career, trying to talk to prime contractors about a continuous vapor barrier. So, of course, poly being the vapor barrier to the interior of the building, trying to into them to use an efficient overall barrier system for the building envelope, but tying that vapor barrier back into the building envelope. So now you have a continuous air barrier. They've really struggled with that idea over the years, and as lasers and us trying to explain to them that this is going to make the building more efficient, and it's been a real struggle, and we haven't been able to get the contractors to jump on board and start to operate in this mannerism.
I totally agree, Gene. The way a thermographer and energy auditor would put that is the continuous AVB or air vapor barrier. Hugely important because not only is a little bit of a thermal break, but more, it's convective action. It stops a convection action. If you can get a continuous AVB, then the one side of the delta is now shut down, which will increase the other two sides of the delta and make your building much, much more efficient. And also, that's where a lot of times where you get sweating and the windows get cold air meeting hot air, and you'll start condensating on your your windows and on your frame.
Absolutely. It would be great. A lot of engineers agree with this system. If you were to move out of the commercial area into the residential area, you try to put this through to a builder out there today, they know absolutely nothing about this system. It's quite unique when you speak to an actual residential builder and then try to explain to them the quality, the performance of a continuous vapor barrier, an AVB, and try to get them to actually do it in the residential stand. Good luck with that one.
I totally agree with you. I've seen that so many times. So many times. So Gene, do you got to go back to your gamma meeting? Are you in the middle of that?
I'm okay for a minute. I'm good. They know what I'm up to, and you know, I wanted to attend this. I thought it was really important to be here today.
Absolutely. And
One more,
absolutely.
I won't keep you much longer.
No,
Uh,
no problem.
when you actually look at our multi-story buildings in the downtown Calgary area, from the curtain wall system, the panel system has been the newest on the market. Now, it's been out there for many years, don't get me wrong, but it is the newest really system that is going up on our buildings downtown. The one thing compared to a panel system to a curtain wall system, the curtain wall system is all erected, fabricated in our shop, but it's all erected and put together in pieces out on site. Field environment, they're done completely within the shop, sent out on trucks and then hoisted into place by crane. A lot of the problems, oh boy, that we are finding downtown at the moment, of course, you know, it really relates to non-certified trades workers that don't know what they're doing. If you were to take Telestar and actually look at Telestar, it's in catastrophic dysfunction. It's in a total meltdown of malfunction. And the money that is going to be required to repair Telestar is absolutely mind-blowing. Not to pick on anything, but you know, prime contractors today picking the lowest bid, not giving the middle bidders or the highest bidders even a chance. And there you go. Telestar is the prime reason why you don't pick the lowest bidder. When you start ripping air seal gaskets out because the panels don't fit together, you've destroyed that system, and and the whole building is leaking like a sieve, right? So not only the qualified, you really need qualified tradespeople. You really do today, and that only enhances the systems that are put within inside these buildings that are erected onto them. Right?
Absolutely. I totally agree. I totally agree. It's each trade is a specialized within itself, and that should be recognized. And I don't think it's recognized as much as it should be. I totally agree with you, because that's what happens when you don't have qualified tradesmen. And sometimes you have a qualified tradesman that is running 60 guys, and then there's communication breakdown. Those 60 guys may not be qualified at all, and that's where you get system breakdown from, for sure. Absolutely, and I see it all the time. Mark?
So yeah, Grant, we should keep rolling with our presentation.
Okay, so I want to get Ben involved here, Gene. So if we can roll it on a little bit.
Thanks for having me. I really appreciate it.
Oh, thank you so much.
Take care.
Okay, take care, Gene.
Hey, Gene.
Ben.
All right. Hey, everybody. Randy, I recognize you in the chat there. I haven't seen you for a couple years. Randy's actually Green Building Technologies at SAIT alumni. And I've connected with him through the years through the Alberta Building Envelope Council chapter in Calgary. So it's been good. So I'm Ben Hilbrandt. I'm currently the principal investigator at Green Building Technologies for Building and Material Sciences. I'm a architectural technologist by training and spent several years working in the building envelope industry in Calgary before coming to SAIT, or returning to SAIT, I should say. I worked part-time with Green Building Technologies as a student. And my journey has really led me to say, like, you know, green sustainable building, it's important for us to do as much as we can, but it really needs to be built upon sound building science principles. We can build a building as efficient as possible, but if we don't heed to the higher laws of building science, then our buildings are not going to stick around for much longer. So I'm just gonna, I got a few slides here. I'm gonna override your screen share there for a bit, Grant. And
Yeah, just unshare there, Grant.
yeah, looks like I can just boot them off here. We'll see how it goes.
Can you?
So I'm going to, screen share nodes can get a bit finicky too sometimes. Let me know, are you guys seeing my full screen share there, or are you seeing
Yeah.
my?
Yeah, we're good.
Awesome. Great. So I'm going to take a little bit of a step back from the curtain wall and glaze and look at overall building envelope here. Start off with this nice example of current architecture right now, State Campus. This is the Aldred Center. Really complicated, a lot of different cladding systems and a lot of complex glazing systems. You can see the structural frames integrated directly with the curtain wall glazing system. It's a really fascinating building to go look at. And this was one that was designed by Gibbs Gage Architects, and I believe it's a few years ago now, I believe it was PCL that did the construction on it. But it's a good example of modern architecture. And so we looked back in time, we can see there's been many changes to buildings in the past 100 years, and even before then. Building Science Corporation has a great article of the history of buildings going back to ancient times of big mass, well, or even smaller mass stone buildings. If we look kind of turn of the century, a lot of commercial buildings were largely brick or concrete block based with little to no insulation, and that kind of goes residential as well for the no insulation part and wood frame. We get, as we proceed through the past century, we get into adding insulation to that. We get into internal structural and insulation assemblies with an exterior cladding mounted on that. We have strip window systems. Were very prevalent, or sometimes referred to as punched windows or window wall, depending on the system. Look at that center photograph there. And then we move into modern times, lots and lots of glass. That's been the style, and it's very important to get it right and maintain that continuity as we've just discussed. But really, to take a step back from that, it's the continuity of what do we need to focus on, and that goes back to building science principles. And this applies to any building that you're involved with, whether it's a new building under construction that you're going to be operating moving forward, if you have a say in making sure of the quality of construction, or if you're looking at diagnosing issues in existing buildings in terms of energy loss. It really all comes back to key building science principles and the key, what's often referred to as the control layers. So depending on where a building is, sometimes you're wanting to fully stop the flow of these properties, but often it's mainly focusing on controlling them and deciding in the design and construction of a building, and also in the maintenance, is how do we want to control these things? We have water, air, and vapor and thermal. So 4 control layers, and these are really key. And on the image on the right there is what's known as the perfect wall. This is introduced by Joe Steebrook from the Building Science Corporation. Kind of, this is the ideal way that we should be constructing a wall for a building. And most small, mid to large commercial buildings are heeding kind of this principle right now. You have your main structure inside with your control layers. Following that, you have your air and vapor barrier, moisture barrier. I like to call your everything barrier. You're stopping water, air, and vapor as well. With that, outboard of that, quite often commercial assemblies now, we're adding insulation, and then we have a cladding layer outboard of that. This is a great system. We're keeping that structure nice and protected, and that's kind of one of the most important parts of a building, and one of the most important parts to repair if it needs to be repaired. So it's best to keep it protected. When we keep it inside and warm and out of the elements, the main structural components of a building last for a very long time. But without getting too deep into the control layers, I kind of want to talk about what faults in each of the control layers might be. And these faults largely come from discontinuities or breaks in the control layers. As we talked about, Gene was talking about curtain wall installation and missing seals and the separation of all the trades. When in my time doing building envelope work, I worked on a lot of commercial, residential, multifamily, all sorts of different types of buildings. And as we get more and more into the commercial area, we have all these divisions of the trades, and the glazer's installing the curtain wall frames themselves. And he's going to hopefully get that nicely sealed to the window opening or onto the next floor, that where the rest of that vapor barrier or weather barrier is going. But who's taking that tie-in from that weather barrier further down? And what happens if we have a gap in there? Most of the issues that we see in commercial buildings are where one scope of work ends and another one begins. And architects, and I know from a building envelope point of view, I've spent many hours poring over commercial detailed drawing sets from Gibbs gauge or dialogue and looking at making sure we have these lines where all these membranes are supposed to go and connect. But when we have this long line of a membrane, and maybe I should have turned off my background so my fingers don't cut out as much. We have a long line of a membrane, but right in the middle is where one scope starts and another begins. There's a lot of arguments sometimes on site as to who should be doing that and who's really going to be taking responsibility for that. Some general contractors I've worked with in the past on commercial projects, I did the building envelope work for the Catholic school that was finished several years ago in Aspen Woods in Southwest Calgary. And the site super there was really good. He had a few guys running around tying up all these loose ends. But that's not the case in many buildings where we get all these loose ends between trades, between scope of works that might get missed. And that's where we can have these issues where we have discontinuities in the control layers. So if we have a break in the water control layer, that largely leads to water entry, and structural damage is the main thing. When we look at the air control layer, and this one's interesting too in a lot of commercial buildings, when we have the mechanical systems and ventilation systems, they can be pressurizing the building to a certain extent, or sometimes depressurizing. So that can amplify any air leakage we have through the envelope of the building. When we talk about the envelope, we're looking at not just the curtain wall and the windows, but we're looking at the entire shell all around that building, from the roof to the foundation, all the walls, and most importantly, the connections between them, between those different assemblies, and all of the holes that we're introducing in those assemblies, whether it be a full window system or a curtain wall. The beauty of a curtain wall system that's really nice is it's essentially hung off the edge of the building and it's wrapped in. So if you have multiple floors, it's continuous past the floor structure, and it's really easy to maintain that continuity. But where we have those connections and holes and different penetrations for services, for vents, piping, or whatever it needs to be, all of those little parts need to be well sealed. We need to maintain that continuity so there isn't air leakage. And what does air leakage result in? Primarily, it results in heat loss, or in some instances, heat gain, depending on the environmental conditions. And thus, we're leaking out that, what I've heard referred to as expensive air that we've already paid to condition, and we're just going to let it blow and leak outside. And thus, we have to pay to condition more air to maintain that space. In the wintertime, in Canada, that air can carry a lot of moisture from the interior environment as it's exiting out through that wall to the outside. When it's below freezing temperatures, that moisture in the air can condense within the assembly, known as interstitial condensation. Sometimes that moisture depositing within a wall or within an assembly that you can't really see, and it can sit there and fester and grow into what I refer to as, I'm not a mold expert, so I just refer to it as organic growth. I don't care what kind it is, what's growing, it should not be growing there. So air leakage can lead to heat loss or heat gain, moisture damage. And one key thing too, with a lot of these larger buildings that we have tenants that we want to keep happy, we have discomfort that can result as well from that. With the vapor barrier, we look at where that is concerned about water vapor that is in gas form, vapor form within the air. So this isn't, we're not concerned about the vapor that's in the air leaking out of the building. This is vapor that's actually going to pass through materials if you have a really bad vapor barrier issue, it can lead to some failures of the building, some moisture damage, but it's very rare. Most important is water and air. And then our last control layer that we look at is the thermal control layer concerning heat loss. And this is a key for energy loss as well, or energy needs for the building. And that's really how much insulation do we have? Where do we have those thermal bridges where we have materials such as concrete or steel that can conduct a lot of heat out of the building in the wintertime? Have steps been taken during construction or repair steps to mitigate, to break those paths? When we looked at those curtain wall images earlier, we have that little piece of rubber that's put under the pressure plate of the curtain wall system that's just preventing that continuous path of metal. More of a thermal break is better, but even just those small amounts of rubber in there, even just a ½ inch of rubber, can make a notable difference in the performance of the building. And thermal too, that also leads to discomfort. When we're operating these buildings, we need to make sure all the tenants in them are happy, so they stay a nice long time. So the question is, what can we do to improve things? And I think a lot of it goes back to what Mark mentioned early on about the holistic approach of buildings. Like, everything affects everything. So in terms of energy, we look a bit more into heat loss. What are the different aspects of heat loss? One of my associates made this amazing graphic for me for some curriculum I did last year, which I really liked. I'm not this much of an artsy guy. I can never make something so pretty. But we have the 3 forms of heat flow: radiation, conduction, and convection. When we're looking at building performance and building energy, we're looking at the conduction and convection. The conduction is straight heat transferring through materials, and then convection is that hot air rises. So, and the convection can have a significant contribution when you have air leakage issues out through the envelope. And air leakage, we have heat loss through air leakage. In some buildings, it can be staggeringly significant. I have heard on a podcast years ago about residential buildings in the UK. There are some buildings where you're losing as much heat from the building in operation through air leakage as you are the sum of all the heat loss through conduction through the materials in the envelope. And it can be very significant. So it's something to pay attention to. And also through air leakage in our larger multi-story buildings, it gets more severe in the upper floors. And that's primarily through stack effect. And largely that's from the principle that hot air rises, and we have these significant tall buildings that gets higher and higher. One of my former associates, he did all of the curtain wall installation reviews for the BOA in downtown Calgary. And he talked about the stairways, the emergency stairways that were in the building. Sometimes they'd have to use them to get up to the roof. And so you have a tall building like that with a continuous stairway all the way down. And he says there are some days it was almost impossible to close or open that door. I can't remember what he said, just due to that majority of air pressure. So pressure flows from high to low when there's a continuous path provided. So when we have all these spaces in the building where the air is connected, that air is just going to go up and up. All that hot air is going to rise. And this also leads to heating comfort concerns in buildings in the summertime, in some buildings as well. And it's something that needs to be taken into account. Some of it can be mitigated a bit through compartmentalization of buildings, and primarily so with balancing heating systems of the buildings. And that kind of leads as well to kind of that holistic building considerations as well. And when we look at heat loss really quick too, that stack effect, we have that higher pressure at the top of the buildings, and that's also where the hottest air is going to be. So if we have any air leakage at the top of a building, we have additional pressure at the top as well. So one small hole of air leakage on the main floor of a building is going to result in a significantly lower amount of air leakage than that same hole higher up with a significantly higher amount of pressure. And that could be compounded as well in larger buildings too. anybody's downtown Calgary, especially yesterday was a really windy day. I was not prepared for my walk to the office from where I park, but the higher up you get, the higher the winds are as well. And downtown Calgary, some densely built environments with larger buildings, they have very unique wind patterns as well. And the wind environmental impacts too can affect that stack effect as well. So when we look at diagnosing, finding where these issues are within the building with air leakage or just thermography, looking at thermal bridge areas, the stack effect kind of amplifies the severity of some of these issues as you get higher up. And it all comes back to what I like what Mark said early on about one system affecting the other. That's like the holistic building considerations. This graphic here is from Hammer and Hand. They're a builder in Oregon. They've been doing high performance homes, passive houses for over a decade. They've got a lot of really good resources on their website, and it's an interesting web that they show. We kind of look at the priorities of a high performance home being comfortable, healthy, durable, and efficient, and this transfers directly to commercial buildings as well. And then we look at on the right of the graphic, we have the advanced building envelope, heat recovery, ventilation, and high performance windows. Like these are key components looking in commercial buildings as well. And then you see that web in between and how all of these things interact within that. So when we make changes to one system of a building, it can impact a lot of different systems. When we look at an envelope upgrade, if we want to significantly increase the air tightness of a building to save heat on energy, that savings in energy demand also greatly impacts the mechanical systems. If we significantly drop our heating load on a building and we have the same BTU rating of an air handler unit, it's going to heat that building up a lot faster. It's going to cycle a lot more. And many of these units are designed for a certain load. They're designed to run longer and not shorter, so you can prematurely wear them out. There's a lot of different impacts that need to be considered when we're looking at building modifications. And it's important to take that consideration too when we're looking at improvements to existing buildings. So that was pretty much what I'd thrown together there to give a bit of a building science background and kind of look at the key components of efficiencies. If anybody has any questions for me, feel free to email me at the email address on the screen there. Randy, feel free to email me with any corrections. Don't bring them up here. And I believe Grant's going to talk a bit more, and then we'll have some questions at the end there. So I will find my button to stop sharing my screen, and Grant can hop back on.
All right. Well, thank you. That was awesome. Made my job awful easy, especially the explanation on convection, conduction, radiation, and that's part of your formula for building envelope, and not just building envelope, but building energy in total. The
I
other.
want to share your screen again.
Okay, do I close this off or what? Where am I sharing? Do I got to share it again?
Yeah.
Or-
Yeah, I stole the
Okay.
share from you.
Ah, okay.
There you go.
Okay, we'll get rid of that stuff. Get full screen going on here. Okay, we're back to where Gene was. So we've covered that, and that was awesome. That was really awesome.
Mhm.
So I'll begin my part of it here. As you guys know, that I'm a level 3 infrared thermographer. There's 3 different levels. There's 1, 2, and 3. A level 3 looks after level 2, and level 2 looks after level 1. So it's always wise to have a level 3 thermographer on your team, especially when you're doing such things as complicated as building envelope. The energy flow in buildings, I think we covered quite nicely. I'm going to try and keep this a little bit short because I know we're running out of time and I don't want to lose the interest of the people. So energy flow in buildings, like I said, that was a perfect explanation of convection, conduction, and radiation and how it works. The complete your delta T. It is absorption, radiation, and transmission, plus convection, conduction, and radiation. Let me go back one step. Absorption side is you got to think of your heating system or the sun. It works both ways. So there's your absorption, radiation, and transmission. So if you're looking at from solar gain side, your heat is traveling to the cold side. So your building is absorbing, it's radiating back, and it's transmitting through. Why I want to note that is just a little bit beyond here. I'm going to add to Gene's and everybody's a little bit just to show what the complication of glass is nowadays. Okay, so those are your two deltas. And then there's a thing called emissivity. Emissivity is surface texture of the different materials that add up to make a building envelope, since we're talking about building envelope. And it has huge effects on thermal transfer. And with those two deltas plus emissivity is actually how we come up with a delta T. And the delta and delta T is, in this case, your outside atmospheric and your inside atmospheric. And so they're always working back and forth to become a mean or the same temperature. So that's your delta. There's a bit more to it than that. I guess I want to keep it short, but the T part is how much energy over time. So that's the T part, and that completes your formula. Now on the conduction side, you have material plus touching material, touching material, touching material. So you have to go through that formula for each one of those materials to actually get your BTU loss on conduction. Whereas convection is quite a bit different. Now you're dealing with both atmospheres, as Ben has clearly demonstrated. And then that has a huge effect on your mechanical, your electrical, and your energy intake machinery, for lack of better words. Okay, so we got the energy flow in building and how it happens. Convectant action is actually a really big formula. I'm not going to get into that right now. It's just, this is an overview or an introduction to. But using thermal imaging for diagnostic tools, important to have the right team, for sure. And just because of the advanced and complicated thermal flow of building envelope per se, and also it's also important to have it ongoing. So I like to do building envelope, say, every 5 years, and so that what it does is that builds up a PM program, which leads to a PPM program, which is predictive preventative maintenance. PM is preventative maintenance. Well, once you have your PM and your PPM down, that creates a risk assessment and also a cost control of, say, a 1, 3, 5 year plan, a 3, 5, 10 year plan, so that your due diligence now can be targeted and correctly followed over a period of time. And that is important on maintenance of buildings, and maintenance of buildings is pretty much what we're talking about with building operators, because that's what they do. So using thermal imaging as a tool, I just brought a couple of images along with me to show the importance of not having the team, but also the methodology of it. Well, let me scroll down here. Okay, first, here's the atmospheric. This should be included in your reports. So these are your atmospheric conditions. Your dew pointing is very important. Ben was talking about that a little bit. When your thermal flow goes through the building and you get the moisture in the air content moisture is a big thing. And if it comes to a point on your mean, as I was talking about, and it goes over your thermal breaks, that's when you get the sweating of a building on the inside. And then I am a certified mold inspector too, Ben. I just didn't advertise that, but since you brought it up, okay. So the harmful molds to human health, they need a few things to grow. One is food, temperature, and the other is moisture. So now if you got your dew pointing that's going on beyond your thermal break and getting onto the backside of your drywall, which is past your thermal breaks, any cellulose product is its food. So now you got food, moisture, and temperature, and it's a perfect place for mold to grow is on the backside of your drywall. So this is what kind of explains a little bit of that. With your barometric pressures as the stack effects that was talked about, wind speed is huge. Like Ben was saying, near the top of a high rise, your wind speeds are faster. Your energy loss is faster, so your delta T is quicker. So that, Ben, thank you very much, covered. Made my job easy. Okay, and then wind direction. Wind direction, it also has relative humidity in there. But wind direction is coming from the north, it comes from the south, it's coming from the east, it's coming, well, not very often east, but anyway, east or west. When it's going on a prevalent side, you got a positive air pressure. When it comes around to the opposite side of the building, you got a negative air pressure. So there it's pulling on the building that way. So that is actually a live load. And that affects the buildings in the sense that all your deflection is counted on in these type of things and is really quite important. And like Ben said, when we're thermal imaging, it's important to understand that because then you can calculate the compound effects from top to the bottom of the building, depending on how high it is and what your wind speeds, relative humidity, dew pointing temperature, and barometric pressures are. So that was about as fast as I can go on that. So let's move down to thermal imaging. Thermal imaging here, I wanted to show this because it actually shows the interplay of the different systems of the building envelope and your convectors you can see there, which has SP4 at 41.8 degrees. So your window is at 2.3 degrees. Now, if heat is going to the cold side, you can imagine how much heat is going through there. And if you look at the thermal patterns, now that is called, what I just explained, is called quantitative infrared. And then there's a thing called qualitative infrared. So if you look at the window sill, you can see little wispy patterns there. You can just see the patterns start to come out along the windowsill. That wispy patterns in qualitative infrared are always air movement. So if you see wispy patterns, it's air movement. Now we know we have air movement. And this is what Ben was talking about. But look at the proximity of the convectors. You can also see the convectors and where the fins are actually placed, because you can see the thermal patterns up the wall. Those are due to the fins that are on the hot water pipes. So now you can see the thermal, you can actually bring to light with an infrared camera just exactly what Ben was talking about. But if we don't do it from the outside and the inside, we cannot do a calculated BTU loss flow. You must have those both informations to actually do the total job. And as you can see, it's all over the place. So how that's done is divided convective, conductive, and radiative over square areas of those three. And if you can get the square areas of those three, and it's never perfectly exact, but it's very, very close. This is the only way you can do it. So that is qualitative over quantitative infrared. And this is why it's important to have the team. So infrared is such a big subject. That is why I took, they're called applied infrared thermography courses. And I had to specifically go into building envelope and roofs. Those are divided into two because they're both huge subjects. Also electromechanical. So that's how I became buildings. Although that I have the capacity and have done global warming and polar bear studies out of Inuvik. I have done that, but my specialty is buildings, and this is why. And why I focused on buildings is because I started out a journeyman glazer. Well, no, I started out an apprentice and then went to journeyman glazer. And I realized back then how important this was because I got into troubleshooting like Gene of buildings. And so when I found thermal imaging, that just rocked my world and I had no choice but to get into it. So I'm going to end with that. It's because I could have gone on for quite a while, but Ben and Gene, thank you very much. You guys made my job way easy. That was really, really cool. Thank you so much.
We're doing well on time here, so it's 7 minutes after the hour. So we still
that
have
was 6 minute
everyone
over.
here.
Mhm.
So there's one question that I'll get to in a minute, but I think Les has a question for you.
Okie doke.
Of course, I always have a question.
Oh,
Yeah, well,
absolutely.
The importance of the of thermography is to put forward a budget so that when we bring in somebody to take a look at those facilities, we're able to show those to the people that do the repairs. Now, do we take those thermographers and use that information in developing a budget price, or do we need to go to, let's say, an envelope engineer to help us with that? You know, to take your picture is one thing, and so it's an interpretation that you give to us on that. But how do we really put the dollar value to those repairs? How do we focus? What's more important? I can see down the bottom of that picture, much more important than what's going up on top, although there are some things going on top that need to be addressed as well. So it seems to be that we need one more person involved in this. You know, maybe it's Ben, I don't know, but somebody's got to come up to make sure that we're not going to get, you know, our money stolen from us.
Right. Did you want to answer that, Ben? Do you want me to answer?
I'll chime in and you can fill in the gaps. I think
Okay.
in my experience, I think thermography is absolutely amazing. It's one of the quickest ways to find general areas where there are issues that requires further investigation. If we send a thermography report and say, okay, we know these glazing areas look bad, let's just have a glazier come in and replace it and prepare a quote off of that. There can be a lot of particular conditions within that can affect the price once the work is underway. Whereas I've learned from personal experience the importance of doing some deeper investigations and sometimes destructive investigations when investigating a certain issue so that we can have the most accurate quote up front, and also most importantly minimizing delays on the repairs. I was involved in a 8-story condo building built in the 70s in the Beltline in Calgary, and we were re-waterproofing a few balcony membranes that were just a traffic membrane on the top floor, and then we found out, and they had these framed guard walls. We knew it was stucco on the inside and siding on the outside, and in re-waterproofing and opening things up, we found, wow, these guard walls are entirely corroded through. on the inside, the metal framing, and they actually weren't framed up properly to begin with. They had less than half of the structure they should have had. It was a wonder they hadn't all fallen off the building. And so we found out probably about 60% of the way through this re-waterproofing job, which involved some other work on the units themselves, that building needed an entire guard wall replacement. So that like halted the work. Whereas if we had even just gone on a couple balconies and cut holes into those walls to see the condition of them, like an extra $1,000 up front, that honestly would have delayed the work happening, any work happening, but it would have given the condo board a way better heads up of what was going on. As bad news as that is, it's more important to get that as early on as possible. As an operator, you're answering to a property manager or ownership of the building, and they're concerned about costs. At any increased price, they're skeptical about, especially when it's stuff they haven't budgeted for when there's any issues. And one of the hardest conversations to have, which needs to be more, we need to get everyone to wrap their heads around it more, is the fact that spending more money upfront in investigation and design leads to savings in the actual execution of the work, because there's fewer unknowns. You can budget for it, plan for it better. And any delays during the work results in cost savings. I was also involved in roof replacement over the swimming pool at the Sheraton on Barlow Trail right before I came over here to GBT. And every time we opened something up, we found more issues and more issues. And that being over pool area in an active hotel, they did not want to have to shut down that room any more than they had to. So there's a lot of considerations where, when possible, to do more investigations up front by bringing in more parties, whether it's a roofing consultant or a building envelope consultant. And I would say, having been a building envelope consultant, it's important to get someone that's honed in on the specific scope as much as possible. So bring in a roofing consultant rather than just an all-inclusive building envelope consultant that'll give you an opinion on everything. And it saves money in the end, in my opinion, or at least you know better off where you're starting off from.
Can I add to that? Ben and everybody else, to answer Les's question, absolutely. A thermographer, there is initial NDT, non-destructive testing. Sometimes you have to go into destructive testing. Sometimes it's just visual, such as the anchors that hold the curtain wall to the building. It's nice to know how those are doing, because sometimes you can get electrolysis and they start to rot off. So this is, the thermographer would be the beginning of the team, Les. And so, yes, would we work with architects, building science specialists, and engineers? It should be done, because as you say, as an operator, you're putting together the costs for the owners or the management team or both. And so absolutely, communication is key, and to have a team, like I said, is that has great communication and great vision. I think that is the correct way to go to end up in a proper due diligence 135, 5310 plan.
Yeah.
Yeah,
Well, I
so
agree
just
with that there,
to interject here a little bit. So remember, I sort of started this off mentioning building commissioning or recommissioning and the process. And the reason why the process is important is because it's, again, about building a team that's going to look at the whole thing. And it's not going to happen all at once. And there'll be several specialties but involved. But there's different milestones in the process, you know, and the first one being investigative. What are we looking at? What are we looking for? What do we suspect? And so there are some things that can be looked at beforehand that kind of hones in what you're looking at, just because the numbers don't look right. And so again, well, I guess what I'm saying is there is a process. And I guess the one question that we did have was somebody wanted me to put up a, a thing for the resource for the Enercan thing I was talking about. So I'll just tell everyone again verbally what to look for. That it's just a PDF it's an introduction to the process is all it is. And it's, so you go to the Enercan website. So nrc.gc.ca. You know, you just go to their website and you can look for the Office of Energy Efficiency, or just on the question bar, just type in tuning up, and believe it or not, boom, the thing comes up, and so the PDF will come up, and you can just download it off the website. And that, again, it doesn't have all the information there, but it's a beginning of the big picture, so that you can put all your resources together and do some thinking about, you know, how you're going to tackle this. Because again, multiple systems will be involved. So we didn't get a chance to get into any electrical today. We didn't even mention mechanical. We spent some time on the building envelope, which was critical. But you know, you have to get it all right, because it all affects the other. And so if you go and just no different than when you were doing the investigating, you know, the project you were talking about, Ben, where, you know, all of a sudden you're 2/3 of the way through the work and like, you know, we haven't solved the problem here because we didn't identify the problem. So that's why the process is critical, and getting the right people on board to drive the process. As an operator, you're probably the one person that will drive the entire process, because you know, ownership, property managers, they're not good at this stuff. They're good at managing money, and so what our job is just the facts, right? So we do the fact finding thing, we kind of roll out and organize how it's going to roll, and then as far as costing, when it gets to that part, then we can start putting that plan together. We can also roll in the preventive and predictive maintenance type stuff, which all kind of rolls into the entire buildings plan. And so you see how it isn't, what's really important is just don't pick the scab off, investigate the disease.
Yeah, I agree. I
Sort of
agree.
leave it at that.
I missed the little part. I was going to tie that in for you, actually.
Okay.
I
Go
missed
for
the
it.
little part, just on the mechanical side, and also electrical and lighting. I'm going to show you a little bit of knowledge, share a little bit of knowledge here that affects both of those. And what I'm talking about is, as the sun travels across a building, let's take this one as an example. You have a south side, you have a north side. And by actually properly insulating the south side and the north side, you can actually ease up the mechanical's job and what Ben was talking about, the stack effect. So let me show you those share this little information with you. So this is PPG's architectural glass performance. And this is what I'm talking about, from the south side of the building to the north side of the building. Depending, of course, longitude, latitude, wind conditions, and such things like that. But this is the knowledge that we have actually today on different coatings. These are the different coatings. You notice ultraviolet and visible, easy for me to say. Anyway, so we have these stats on all the coatings on glass now. It goes, I'm just going to take a minute to do that, but you can see it's squared, transmitting squared, right? So that's what I was talking about, square area, glass. These are your different low E's in this particular thing. I just had to take a screenshot with my phone and put it up on this screen. So I don't have the whole thing for you, but I give you a couple of examples here. So this is, you've seen the ultraviolet and the visible. You have, I can't really scroll down and my thing's in the way, but it also gives you the total solar energy, exterior light, interior light. That's what I was saying. It's important to do the interior and the exterior and your winter night and your summer day. I always say get into the different means of temperature that can transmit through this glass with all the new coatings on it. So we do have those stats on it. It has the UV, the shading coefficient, solar heat, solar gain, and light to solar gain. So this is the information that we actually have this information now, whereas just a few years ago, we didn't have that information. So PPG has it on all their glass. It is available on their website. If anybody else is into building sciences, but this is some of the stuff that actually affects your electrical and mechanical. It can ease your mechanical, and it also can help with doing your calculations of the heat generated from, say, LED lights or T12s or whatever you have in your building, and so it can help you with the interior comfort of your building. So that's what I was talking about when I didn't mention, because Ben had mentioned it, the comfort of the building due to atmospheric
Well,
data in the building.
it's also important to realize that well, all glass is not made equal, but when you're replacing glass, you try to replace with equal or better to what was there, but you need to understand why that particular kind of coating in that glass was used in that location. And it varies as you go around the building.
That's
And
right.
it will have a direct dramatic effect on your mechanical system if you don't get it right. Because you're changing the load.
That's right.
And so all your heat load calculations are out if you don't maintain the datum, right?
Right, and so this is part of your heat load calculations. So that we can actually do that for mechanical systems and electrical systems now, whereas before we couldn't. Yeah, so we do have some great information on this kind of stuff now. And anyway, I just forgot to show you guys that. I thought
No sweat. We're sort of carrying on a little bit long here, so
yeah.
So I guess we should.
I've got another meeting here in about 7 minutes.
Well, it's all good. Good timing. Is that a meeting with the? Was it Kootenai Ale or?
Hey, no. Okay.
I wish we could buy it in Alberta, or I'd call a meeting right now.
Yeah. Some folks from Texas and from Calgary, actually. So I don't want to miss it because they're Texans and I don't get to talk to them.
That's important. Okay, so we'll wrap it up then, and thank you very much, Grant and Ben, and we've already thanked the sponsors. Next month, our meeting, I believe, is on the May the 10th. I think I've got that right. If I don't, oh well. Second Tuesday in May, and I haven't come up with a subject yet, but guaranteed I'll come up with something good. Perhaps it'll be more related. As far as feedback is concerned, it'd be nice to hear back from you folks to see. We would like to, we glanced over a whole bunch of stuff here, but and any one of those topics deserves, a whole webinar in itself. so you can see where in the future, perhaps from an educational point of view, there's an opportunity here to do a deeper dive into each subtopic, the stuff that we just glanced over. And so the information just goes on and on and on. But you can never know too much about this, and you need to learn what resources to reach out to, because you're never going to know it all. But you also need to learn how to quarterback the whole thing, because it's like herding cats. They'll be all over the place. So our job as operators is to keep things under control and even keel, and make a plan and then execute that plan. So I'll leave it at that. And